Okay, so the last little bit we're going to be talking about is the graphs of the 6 trigonometric functions, okay? We're going to look at pretty much all of these. The ones that we're going to be looking at in main detail, however, are the sine, the tan, and the cosec are the main ones that we're going to be looking at in a bit more detail. Okay, so let's say that you were to graph the line. Let's say you wanted to graph the line y is equal to x plus 4. Okay, how do we graph this line? Well, the way we introduce it to you is that we say, we'll draw a table of values, okay? Put in some numbers, -2, -1, 0, 1, and 2. And then put those x values in replace in our equation to come up with a bunch of points. So -2 plus 4 is just equal to 2. And this one's going to be going up like that, okay? And then you come up with some points that will make that equation true. However, the type of function that we're going to be dealing with is going to be a trigonometric function. So let's work with y is equal to sine x, okay? So our increments for this will be going up by 15, because I think 15 degrees, so like 0 degrees, 15 degrees, 30 degrees is probably the most appropriate one to do. And we're going to go up to 360 degrees. So let's start by putting in our values. Look at that, it's already auto-filling it for me. This is why Desmos is the much superior. And when we do that, okay, we're going to then substitute those values for x, or for theta in this case, from our calculator into our table of values. So let's start off with our 0, so sine of 0. So put sine of 0 into our calculator, and we should just get 0, nice and easy. Then we're going to put sine of 15 degrees into our calculator, and we'll round it to 4 decimal places. So it's going to be 0.2588. And what you'll notice about this one is it's quite small, like it's quite low down there. Okay, the next one we're going to do is sine of 30 degrees, and we remember that's one of our, what do we call it? One of our exact values, our exact ratios, okay? Next is sine of 45, which is another one, it's root 212, okay, but we're going to approximate it just for the sakes of the argument, so it's 0.7071 in that one. Then we're going to put in sine of 60 degrees, which is root 3 on 2, but that's 0.8660, okay, to 4 decimal places. Then we're going to put 75, sine of 75 in, and that's going to give us 0.96, so 9659, okay? And then finish off with sine of 90, which is equal to 1. So looking at the graph that we've got so far, we've kind of got this little bit of a curve. So it sort of goes up a bit and then it flattens out again. Okay, so let's continue going. Sine of 105 degrees. Okay, well that's 0.9659 again. Okay, and then 120. So you should be coming across the pattern pretty shortly that, you know, remembering back to our angles, our angles, what do we call them? Oh, I can't even remember what it is. Our related acute angles. Okay, so these will all actually overlap and be the same as their counterparts. And we know that in the second quadrant, sine is positive. Okay, in the first and the second is positive. So they're all going to be exactly the same. Okay, 2588 and 180 is 0. So looking at this graph, it goes up, and then it starts to come back down again. Okay? So once we've put in those values, we can kind of see what's happening. Now, you might think to yourself, well, doesn't that just mean that it's going to start going back up again and doing another lap? But you may remember that in the third and the fourth quadrant, sine is actually negative. So what's going to happen is the numbers are going to repeat themselves, but they are going to just be the negatives. And we can test that as well. So we're going to put sine of 195 into our calculator, okay? And we're going to get a negative answer. And it's going to be negative 0.2588, which is the same as 15 degrees, but just a negative. So again, these ones are all going to be the same. except the negative versions. So let's put these ones in. So 07071. Okay, 240 is going to be negative 0.8660. Okay, 225 is going to be negative 0.9659. Okay, negative 270 is just negative 1. And coming back the other way. So again, this gets to this negative 1 point, and then it's going to come back in on itself. So negative 0.9659, negative 0.8660, negative 0.7071, 330 is going to be negative 0.5. Whoop, I did a comma, not a point, 0.5. Okay, 245 is going to be negative 0.2588, and negative 360 is just going to be, well, I was going to write negative 0, but it's just negative, it's just 0. So as you can see, we've got this loop that happens. Now, remembering back to what our acute related angles are and our general angles are, once we start going past 360, remember it does a whole revolution of that circle. Okay, so once it does a whole revolution of that circle, and it's just going to repeat this pattern again. And in fact, the pattern's going to continue both ways, so both left and right. Okay, so this is what we call the sine wave, or the sine wave or the sine graph of the sine function, or the graph of the sine function. Okay, so it's between 1 and negative 1 on the x-axis, because it's only going between the negative 1 and the 1 on the y. Okay, as you can see with my values on the left. I would use my mouse, but it's decided not to work for some reason. Okay, and then from 0 to 360 degrees, which is our 0 to 360 along the x-axis. Okay, so let's put it up against next to the y, to the actual function itself. So I'm going to turn that on if it's going to work for me, which for some reason it's not. Why aren't you working? There we go. And there it is there. So those points go straight on that value there. If I move it around, you can see it continues back that way as well. And this one here continues along that way as well, like that. Okay. So that's the sine. That's the sine function. The other one we're going to have another look at, or a quick look at, is the cosine. Now, cosine's a little bit different. We're not going to draw this one up, but the cosine's a little bit different, but only a subtle difference. If I shift it back just a little bit, till I get to, let's say, I want to get to 90 degrees. If I shift it back 90 degrees, you'll notice that it's exactly the same. So the cosine function is almost exactly the same, except the only difference is that it's been shifted 90 degrees across. Okay, so this one starts at 1 and then goes down straight away. Then at 180 degrees, it turns back and starts going up. Okay, so that's that one. So let's have a look at the tan function. So the tan function is, well, tricky on the best of days, let's just say. So we can do the same thing for our tan function, and I'm only going to do between, let's say for this one, between 0 and 90 degrees. Okay, so you'll see why I'm only doing between 0 and 90 degrees in a moment. Oh, so I don't need that 105. So let's go into our calculator and put some values in. So starting off with tan of 0. So tan of 0, well, that's just equal to 0. Nice and easy. Okay, tan of 15 degrees. Well, that's equal to 0.2679. Okay, 30 degrees is equal to, so 30 is, oh, actually, no. Let me restart this one, sorry. Get rid of this. Oh, for God's sakes. Get rid of this. Put in a new table. And we're going to go from minus 90 up to 90. Up to 90. I've decided it might be a bit better because it will actually show us what's going to happen. So I'm going to continue starting at 90 anyway. So 0 to 15. So tan of 15 was equal to 0.2679. Tan 30 is equal to, well, that's the root 3 on 3 one, so it's 0.5774. Okay, tan of 45, just putting these into our calculator, gives us 1. Okay, so have a look at this one. This one's going up much quicker than the other one was. Tan of 60 is equal to 1.73. So this one, in fact, actually goes further than 1. 17321. Okay. Tan of 75 degrees is equal to 3.7321. Okay, now look at this one. And you'll notice that 90 degrees, it's not actually going to help us too much with this one, but 90 degrees gives us the math error. So I'm actually just going to leave that one where it is. Now, for this one, so we can see that our graph is shooting up very quickly. And so the closer and closer and closer it gets to 90, the higher and higher and higher it gets. So remembering back to our limits that we've done before, we can actually find what the limit is, or we know that the limit is going towards infinity, because the closer and closer and closer we get to 90, the bigger and bigger and bigger tan gets. So even if you put in tan of 89, you get 57.28. If you put 89.5, 114, 89.9 is 572. Like, the more and more and more closer you get to to 90, the bigger and bigger and bigger this number gets. And even the small changes of the fraction makes this thing grow extremely bigger. Now, going the other way, tan of minus 15 degrees gives us minus 0.2679. So it's going to be basically that same pattern again, but in the negative direction. So 2679 minus, 30 degrees is going to be minus 0.5774. 45 is minus 1. Nice and easy, that one. Okay, minus 60 is minus 1.7321. 75 is minus 3.7321. And again, if you try to put minus 90 into this, we're going to get a math error as well. Okay, so as you can see, we've got this crazy looking contraction going on here. Let's have a look and see what the actual function looks like. And there it is. So this is what we call the tan function. Now I'm going to zoom out a little bit to show you, because this thing keeps repeating. We've got a bunch of different asymptotes at every increment of 180 degrees. So minus 90, 90, 270, 450, and each going each way, there's these asymptotes because we can't evaluate the tan value or the tan function at those values, okay? And so we get these parts where my function starts shooting off towards infinity the further right I go, but then comes from infinity from the left-hand side of each individual section, okay? So this function is not defined at negative 90 or 90, but it's a cool-looking function nonetheless, I think. And it's very, very cool to see. Now, another one of the functions we're going to have a look at quickly is the cot function. Now, cot, remember, is just the inverse of the... Not the inverse, sorry, I keep saying that. The reciprocal of tan. So cot of x, well, look at that. It's almost just an exact flip. Except you'll notice now that instead of the asymptotes being on the 90 and minus 90 and every 180 increment on that, it is actually, the cot function is actually undefined at 0 degrees, 180 degrees, 360 degrees, and then every increment of 180 each way on that. So another really cool one. So the last function I want to do, and in more detail, is we'll do the sec function, because the sec and the cosec are also related. So sec of x. So remember, sec is the cos function, or the reciprocal of the cos function. Okay, so let's do our table of values, and this time let's go between 180 and 80. So, sorry, negative 180 and 80. So negative 180, and we're going to go up this time by increments of, we'll go up by increments of 30 to make... Oh, no, we'll go by 15 still. So negative minus... or negative 180, negative 165, 165. Okay. And then I should be able to do the rest going down like that. So quite a few there for this one. Okay, so to put this one in a calculator, we're going to do 1 over cos of negative 180 degrees. Okay, and this one gives us negative 1. Okay, so of negative 165, okay, putting that into our calculator, we get, okay, minus 1.0353. 0353. Now remember, for our reciprocal functions, whenever we're taking the reciprocal of a number that's quite small, so between 0 and 1, our answer is going to be bigger than 0 and 1, and vice versa as well. It's just one of those facts about a reciprocal. So we're going to keep doing this, and I'm just going to go to the point where it's going to start repeating itself and then fill in everything. But if we keep doing this, so these ones are going to give us negative. So this one's negative 1.1547. Oh. 0.1547. Okay, so you can see those points right now and see what they're doing. So I'm just going to move that along there a little. Oh, actually, no, I can stay in the middle. Actually, I can zoom in a bit calmer for this one. Okay, so you can see these points currently, what they're doing. So it's quite interesting, I think. Let's continue going. So our next one is 135. Okay, so that one is minus 1.4142. Okay, this one is going to be 120, so, oh, I keep getting syntax error, which is annoying, so 120 is equal to negative 2. Okay, negative 105 is going to give us, so 1 over cos of negative 105 is going to be negative 3.8637. Okay, and a negative 90. Okay, so negative 90. I'm going to put that one in as well. So negative 90. And what you'll find is this one is actually a math error, because we can't have, well, cos of 90 degrees or negative 90 degrees is 0. So you can't have 1 divided by 0. So that one is actually a reciprocal. That one is actually undefined. So continuing along, we're going to get our positive values now. Okay, so we're talking about the fourth quadrant where cos is positive, and this one is actually going to give us the same value there. And these ones are going to be the same, but the positive version. Ooh, 1.30353, and 0 for this one's going to be 1. Okay, and so you can kind of see what's happening. So I'm going to just keep going with this pattern. So after 1 we go, oh, actually we haven't done 1 yet, so I'm going to put some more values in. So cos of 15 degrees is equal to 1.03, so 1. Oh, in fact, it's actually going to start repeating itself again after these points. So it's actually going to go back the other way now. So it's kind of doing like a cup. Okay, so 1.0353, 1.1547, okay, 1.4142, okay, 1, and then we're going to go 2, and then we're going to go 3.3837, okay, and it's going to go like that. So our line will continue like that. So you can kind of see we've got some asymptotes like that. Now 90 degrees isn't going to work. 105 degrees would be starting this one again, but in the negative direction. So I'm going to leave it at that for now. And what I'm going to do is I'm going to turn this graph on, and we're going to see what sec of x looks like. And there it is there. So obviously a little bit out because of the rounding errors, but so if I zoom this one out, we can see this function, and this is a crazy looking function. Okay, so absolutely crazy. So let's compare this one to its counterpart. So sec goes with cos, and we'll compare the two different parts. So as you can see, the asymptotes for sec happen at the point where the cosine is equal to 90, or where x is equal to 0. Because if we're putting 0 in that sec function, it doesn't actually exist because the reciprocal can't happen. Okay, the values are the same when it's 1, okay, because the reciprocal of 1 is just 1. And then when our function is going down, when cos is going down, sec is actually increasing. Okay, so just a really cool little fact there, factoid. And so that is cos. And of course, if we compare sine, okay, so having a look at sine, automatically we can say, well, if we're taking a reciprocal, that there, and that there, we're going to be asymptotes, and my function is going to be 1 there, and there, and there. Let's have a look. So cosec doesn't like cosec in this. Let's have a look and see what's on my function list. Functions. It's CSC for cosec, and of x, and there it is there, and it's pretty much as I said. So asymptotes at 0, 180, negative 180, and 1 at 90, negative 90, negative 270, etc. Okay, I think that's all we need to have a look at for those ones. So those are the functions. Get yourself familiarized with them. Mainly sine, cos, and tan. Those are the big ones. The other functions you can pretty much just get from the fact that they are reciprocals. But other than that, thank you for watching.